Hello, I'm Mark Rosewell, and I'm here today to talk around private 5G. It's a common question, but the difference between the two, it's in the name really. So with a 5G network that we commonly see on our phones provided by the carriers, EE, O2, and the likes, is managed by a public infrastructure. With the private 5G, we are actually installing equipment, local equipment on the customer's site, then service a licensed spectrum that we actually get through Ofcom, so they get guaranteed connectivity to that spectrum. When we connect to the public network, it is a general shared spectrum that we use from there. I think the best way to explain it is if you own your mobile phone, you have a SIM card in there that is linked to a carrier that will connect to their 5G network. We provide a SIM card that will connect to our private 5G network. So it is completely separate from the P5G. Now, we do see a lot of requests where a customer, they think they want private 5G, but actually what they want is a boost to the signal of their 5G network, which we can also do that as well. The biggest difference is they serve different purposes. You know, from what we see of our customers and what we are deploying on a regular basis. Now, P5G, we are seeing as a wider coverage area. So we can do it in big outdoor spaces. It has strong security embedded into it. It's highly reliable, as I touched on before, because we are using a licensed spectrum that we get from Ofcom, so a specific spectrum. And it does make it ideal for those kind of larger enterprise or the bigger kind of IoT environments that have to span external or outdoor areas. With Wi-Fi 7, that's an extension to the standard Wi-Fi that we're used to when we walk into any building. It is, again, it's ultra fast, ultra reliable, but we see that more for our offices or university campuses for indoor purposes. Now, we are doing projects at a minute where we're actually using the P5G network to backhaul or transmit data that comes off a Wi-Fi 7 network. So we can incorporate the two for some of our solutions, but as it stands, the technologies, they are completely separate. With Wi-Fi 7, we need to be able to connect that to a data network. If you look at P5G, is that data network. If we did have a customer, and we do have customers now that have a large distribution business, they've got a large site, they would have to install a lot of Wi-Fi equipment to cover the ground that they want to cover, and we could not give them the guarantee because it is Wi-Fi that uses a standard spectrum or standard frequency to connect. So if customers have a mobile workforce that have kind of different ways of connecting in, that's we see, especially external areas where we see P5G being better. When they have laptops only due to work services, that's when we see the Wi-Fi 7 for indoor purposes is the better fit. The best way to put it is P5G for wider scale external areas and Wi-Fi 7 for indoor wireless networks. Two sides to it. Is it safe to be able to connect securely? And for obviously my staff members or my customers be able to connect in. And then there's the regulation side of implementation of it, because we are using a licensed spectrum within that. So I think the answer is yes. Short answer is yes, it is safe. I think from security, we're able to implement different security features in there to make sure the data stays local. We can put encryption in there as well. We can then make sure that we're using an additional security appliance like a network access control system. We can then control who actually connects to the network as well. So from what keeps network engineers awake at night, yes, we can give you a nice, safe, secure network that we can guarantee that only people that are allowed to connect to that network will. With regards to the implementation and the regulations, we have a tried and tested delivery model at Logicalis that we go through at the same time to make sure that the networks are designed in a way that we can make sure that we hit all the compliances and that we can update regularly. If we compare P5G to 5G, you're on a private network, so you control who connects to that network, compared to public 5G that anyone, if you're on the same carrier, you're connecting to that network. We do the same with our Wi-Fi 7. So there are, I think from a security point of view, there are a lot of similarities between our P5G solutions and Wi-Fi 7. It's the difference, I think, scale and the distance that we can actually connect to using those different technologies. So when we're talking about the speeds, we're talking about the speeds within the environment. There'll always be a gateway out of that network. And as soon as you go out of that gateway, you're into the areas that we don't have the control. So, for example, in this instance, the link to a P5G could be a BT network or a Virgin network. As soon as we hit that gateway onto theirs, then we're into their world. So, what we try and maintain is the speed and the reliability within our private 5G network. Look, as a networks engineer, it's never the network. The network is the most reliable element of it. It's always the back-end infrastructure. But with a scenario that you are getting a degradation of service, there could be a number of factors for that. What we're standing by now is within the P5G network, so the network that your devices, your laptops, your phones, your iPads, your barcode readers could be connect to, will have a guaranteed connectivity rate that we're seeing anywhere between 500 meg and 2 gig. If you have a server that also connects to that, they will share that bandwidth and that throughput. If that service sits externally, then we are pretty much governed by the world that they live in. Ports and transport and distribution seems to be the ones that I think the delivery teams that give them the most challenges, because they are fast-moving environments. You've got a lot going on. Obviously, you've got ships going in, you've got straddle carriers, you've got, there's a lot of moving elements. So I think being able to provide infrastructure in what is typically, historically been a very difficult environment to connect, I think that we're seeing the most kind of, rewards from that. But the common ones that we see, and then we're speaking to our customers about in, across a number of verticals, is manufacturing. We're seeing the real-time control of kind of machines and robotics. They're using it because of the scale and the speeds that we can actually provide. We've got airports and stadiums. So as you can probably appreciate, in the airports and stadiums, they've got a high density of users. So we're able to provide connectivity for high density users and also use that for a surveillance if needed. Within healthcare, we're talking to people around secure telemedicine and remote connected devices, again, because of the large geographical areas that we're able to cover. Defense and blue light, again, very similar to what we saw in the telemedicine. We're using secure, reliable communications. When your public networks are saturated, we can then backhaul onto our private 5G solutions. Utilities, for kind of remote monitoring of the grids. So a lot of the utility companies have infrastructure all over a kind of geographical area. Because of the range of P5G, again, we're able to connect those and they'll be able to monitor those to see if there's any faults or any kind of degradation in service. And finally, obviously, mining, the equipment they use in miners. And mining, we're able to connect them, making sure they're up and making sure that they are safe and the people that work in those environments are safe as well from connectivity into the network.